Thank you. So, hello, everybody. Thank you for attending. So this is Hyper-V Network Virtualization, 100-plus customer service provider deployments. So quite a cozy environment. Thank you for coming. I believe this is probably important to you, and that's why you're here. The fact that we have a small audience, well, so don't be afraid, engage. Feel free to ask questions at any time. We also have Anand from the product group here. So we'll try to make this as interesting as possible for you. This is our agenda. So we'll explain the scope of the work we do with service providers as part of something called CloudOS Network. We'll go through a level setting of Hyper-V Network Virtualization as a technology, more or less a bit of a primer for those who don't have any experience with it. We'll cover some of the HNV scenarios that service providers are implementing. So what are the go-to-market opportunities and how HNV can be used today to bring solutions to customers if you're a service provider. And then we'll move to the core of the session, so the learnings and best practices, the things that we think you should be doing when you're starting your journey with Hyper-V Network Virtualization. And at the end, we cover a bit of the ecosystem, partner solutions that can complement our inbox HNV solution, and we tie a bit to some of the announcements that were made during the session around Windows Server 2016 and System Center 2016, and the future of our software-defined networking story. There's some time reserved at the end for questions, but again, feel free at any time, come forward and just interrupt us and ask anything. So CloudOS Network is an internal Microsoft program that has been running for about 3 years. It started small with about 10 service providers around 3 years ago and has been ramping up, so growing with the number of customers and partners that we're working with. We currently have around 200 partners in total that we're working with. Around half of those have reached what we call production status. They have offers in the market. They are Microsoft partners that are spread out around the world, and any enterprise customer can engage with them and use them as a CloudOS solution provider. So, before we start, because we're few, who here is a service provider? Okay, very well. So for the others, are you looking into deploying HNV in the enterprise world, or just trying to understand a bit better of our SDN solution? Yep, some nods, basically. Okay, very well. So I'll try to shape the message a bit around this context. So Hyper-V Network Virtualization, if you're familiar, and I hope you are, with the context of server virtualization, where it allows you to define compute resources, storage resources, networking resources, in a way that basically allows you to virtualize them, define them in software, maximize the use of the hardware, and minimize the changes to the physical components that provide that infrastructure. So if you take the same principles and you apply them to your network, software-defined networks and network virtualization in this regard basically tend to bring this same level of benefits into the way you think of networks. So keeping your physical network as static as possible, so providing the least disruption to your physical network, and allowing every service, everything that you provide to your customers or your business units to be defined in software, becoming way more agile, and the less changes that you need to do in your physical environment, the more reliable and the higher the service level you're providing to them. So there are a number of functions and a number of terms that I'll hope these slides will serve to pass along. Who here attended the previous HNV sessions that were here, particularly Greg and Scott's session on building network virtualization? Nobody. Very well. So do interrupt if something is missing here, okay? So think of the underlying level here. Compute host group is your Hyper-V compute, okay? So where you run your tenant workloads and where you run all your applications. So this is typically a world where you understand the concept of a virtualized virtual machine. With HNV, network virtualization, you basically expand that context into also defining networks as a virtualized resource, okay? That context becomes what we described here as the HNV network, and you see represented by these different colors the various different tenants that are isolated in this HNV network, okay? On the left here, you have System Center Virtual Machine Manager, which in the current solution, and everything that we're talking about here today is about the current solution that's in market, so nothing here is related to some of the announcements and what's coming in our next version of Windows and System Center. So Virtual Machine Manager acts as the intelligence of the solution, as the brains of the solution. It's the control plane. It maintains all the data that every single Hyper-V node there needs to know to maintain the consistent state of that virtualized network. So it is very critical that Virtual Machine Manager is available, is well maintained, because it maintains the core information of our software-defined network. So it also is responsible for updating any information. So when a new server is provisioned or when an existing server is moved in any way, so all of this information needs to be made available to all the hosts in your compute environment, okay? So this is the function of the control plane, okay? It's to register all those changes and make sure everybody that's participating in this environment is aware of them, okay? Finally, so when you think about software-defined networks, they exist only in software, right? So the coexistence of a traditional network and a virtual network needs to be done by an element that understands both, okay? In our solution, that element is our network virtualization gateway, which is a role that sits at the edge of the network, has network connectivity to the side, to the software-defined side, so our network, our virtualized networks, and also has connectivity to the edge of the network, basically the physical or the traditional networks that can be accessing your virtual network. So this can be an internet-facing network, can be, if you're an enterprise, something that sits on your enterprise network. So again, and in the same context, it's also the control plane, so Virtual Machine Manager, that's responsible for maintaining the information of the available gateway, so the roles that allow the networks to communicate outside, and also all the information required to provide the path to traffic when traffic is coming in a direction of a virtual network. Our gateway supports also BGP as the protocol for advertising routing information. So if you have a customer that's consuming or connecting, consuming any service or connecting to the gateway, for example, via a VPN tunnel, it can use BGP to gain knowledge of all the networks that are created inside the virtual network. So let's think a bit about what's exactly inside a virtual network, okay? So far, you've seen networks represented in multiple colors. Think of them as different tenants or business units that require isolation. So virtual networks here represent an actual boundary in the communication, right? Nothing here can escape a virtual network without a specific gateway, the role that you saw in the slide before, providing that connectivity, okay? So when you create, as one tenant, you create a virtual network, this virtual network needs to contain another element called an address space, okay? This address space is basically the definition of the IP subnet that is configured for this virtual network, okay? So the virtual network context can have more than one address space. And because it is an isolation boundary, anything that sits inside this virtual network space can route immediately. So if you have multiple IP subnets defined in a virtual network, these will automatically be able to route between each other, okay? If the same tenant creates a second virtual network with a single address space, for example, the default behavior with the current release of the product is not to allow any routing, okay? So for this, and because we treat virtual networks as what we also call a routing domain, so for this to be possible, you'd actually have to come and route to an on-prem, so to the connection that would be initiated from the outside. It would have to use a device in your enterprise network, for example, to be able to make the path between these two, okay? So a customer view. So what the customer sees. Who here has used Windows Azure Pack? You're familiar? Very well, okay. So similar to Azure, the Azure Pack is the on-prem implementation of an Azure consistent solution, okay? One of the services that are implemented in Windows Azure Pack is virtual networks. And this is what the customer sees when consuming this service, okay? So we're going to map a bit to some of the context and concepts that we already discussed. So in the Networks tab on the left, it is possible to create one or more virtual networks. And these map exactly to what you see here. These are these two large objects, the containers, and they're also known as routing domains. So inside these virtual networks, it is possible to define these address spaces, and you see them here. So you'll see a typically /24 network. This is typically internal addressing space, and you can define as many as you want, okay? You have the ability to see also the virtual machines. Once you provision them, you can have a quick view of every machine that's basically connected to a virtual network. Another example, so for the same tenant, also the ability to create. So if you want to create isolation zones within your hosted environment, you can use more than one virtual network. So again, the list of servers and okay, so now let's dive a bit deeper, okay? So what does the provider view? So you saw that the tenant view, I create virtual networks, I create basically IP subnets where I can create virtual machines and attach them to those virtual subnets. But the provider has a very different view. So if you think of a service provider using software-defined networks to any customer, and any customer can come in and define their own address spaces, we need to be able to deal with IP address overlapping, okay? And this is where we start to introduce the concepts of a customer address space and the provider address space, okay? So these objects that you've seen before, right, the virtual network and the address space, how does a provider actually perceive them? So the first virtual network is in VMM, a VM network, okay? And here, I think there's some feedback already that anywhere in the stack, things have different names. So it's quite hard to kind of match them as you go through the different products. So Windows Server, System Center, and Azure Pack, things have slightly different names, okay? So you see the customer ID over there on the top, and the VM network here that's created. This is basically the internal representation of this object, so this virtual network here, okay, that contains, in this case, these two virtual machines. Next. Very well. So the second virtual network is represented actually by a completely different customer ID. It doesn't make a lot of sense in the name that's used here. It's just the PowerShell field name. But this in reality is the routing domain. Okay, so it's that routing instance that you see that we discussed before. Okay, so the common term that you see on the end user UI is that virtual network. So the tenant sees their address space, so what they define here, okay? And many tenants can actually have the same address space. It doesn't really matter for the provider. Those address spaces are contained by the concept of the virtual subnet ID and the routing domain. So think of them as traditional VLANs, right? So in the sense that there's an ID that it's used to basically provide some degree of isolation between those various networks, okay? So the customer address you see here is defined by the tenant, and in System Center Virtual Machine Manager is what you know as an IP pool. Okay, it's defined there as an IP pool. It's visible. There's an independent ID for each, so you can see also back here the blue one has a very different ID. Okay, so if you recall from the earlier slide, I mentioned the possibility of having multiple address spaces, right? And you can see them also here and there. Okay. So this is where we start to introduce some of the things that you need to be aware of when you're building a solution and bringing this to market, okay? So for example, if you're leveraging Windows Azure Pack, Windows Azure Pack will default to only use the first address space that you configure, so that first IP pool, okay? However, Virtual Machine Manager, for example, already allows you to connect this to any other of those, okay? Meaning that there are differences in some of the functionality depending if you're using the complete solution with Windows Azure Pack or if you have your own portal that you're developing and using only the core platform to support you. So the different levels of functionality are expected, but also some of the feedback that we're taking in from service providers in the sense of what's more or less important. And this is also one of the key items that's already in consideration for deployment. So Windows Server and System Center are accelerating their update and release of new features. So if you use System Center, you notice the cadence of update rollups that are being released. So new functionality will come, and this is actually one of the items that has been already requested. So finally, in the terms of the CA space, one critical element is the default gateway that each address space has. This default gateway is managed by Hyper-V Network Virtualization. You are unable to change it. So we reserve for us the .1 address, and this is the way out of that virtual network. It's managed by the HNV extension in the virtual switch of each host. So wherever a virtual machine lives, the virtual switch on that host will always respond as the default gateway for that VM, okay? And then it's that information that that System Center Virtual Machine Manager, the control plane has, where everything else is, the gateways, other VMs on that virtual network, if you need to route or not. It's that information that then will be used to actually get the traffic to its destination. So, but this is all software. Okay? None of this actually exists on your physical network, okay? What actually is there, sorry, one thing to mention, and I'll be back here. So what actually is there is the provider address space, okay? So this is the network you define that actually is what you see. So if you use any traditional network analysis tool and you're looking at the traffic moving back and forth between your Hyper-V hosts, you'll only see these IP addresses being used. Okay. So just going back here, there's one special network, and if you use Windows Azure Pack when you're provisioning a virtual network, either in Azure Pack or in Azure itself, it's going to ask you for a specific network. That needs to be something that you don't use on your enterprise network. So as you define your address space, you need to reserve some space for the gateway itself, okay? So this is the network where we provision the customer address space of each gateway. So when a VM needs to route to the outside of the virtual network,
it will use IPs that are defined in this network here, okay? Also, these are, so the .2 address, .3, .4 are automatically managed by HNV also, so not something that you should expect to change. Although you can define the network side of this, the DEN 254, 254. If it's something that you use on your own environment, you can specify something different here. Okay. So this is a simplified view of how packets actually move from one virtual machine using a software-defined network to another, okay? So imagine this is actually the same network, two machines, so IP 10.0.010, 10.0.021, and we want to send a packet from this virtual machine to the other, okay? So here the machine doesn't know anything about virtual networks. To him, it's just another connection to the network. It will deliver the packet to the virtual switch, right? Here, the Hyper-V host will understand where the destination is, so it has that information that's maintained by Virtual Machine Manager, and it will add the necessary information, the encapsulation that is provided by NVGRE, the protocol that we use for encapsulation, and this protocol will contain the virtual subnet ID, so typical, a concept like a VLAN, right? But that allows us to have way more isolation, so it's a much bigger number there. And it will encapsulate this with a frame that it tells it what's the destination host for this packet. And then this is what you see on the network. Basically, the frame is delivered, and it gets the destination host. The virtual switch there removes the encapsulation and delivers the packet to the destination. Okay? There are other scenarios. Not everything works like this. This is just a simplification, so how the traffic moves on the same host, between different address spaces, to the gateway. There are many things that are important. Okay. So recap a bit some of the terms we used. Okay. NVGRE is our encapsulation protocol, which is a slight change to the GRE protocol that was, I think, designed by Cisco. So it's very similar in nature. There's basically a GRE key in the original protocol. We have extended that with just some other information to allow us to manage the tenant information. The concepts of customer and provider address space, so networks that are defined by the tenants, that are hosted only in software, and the corresponding provider address space that is actually the network that moves data around. The control plane, so the role of Virtual Machine Manager to maintain a consistent view of the network information, and the concepts of routing domain ID and virtual subnet ID, which are basically the virtual network and the multiple address spaces that you can have inside that network. Okay, so some of the scenarios that some of our partners have been building. These are what we call the hero scenarios for V1. So many people tried to do many other things, and for the worst part of it, they were somewhat unsuccessful, okay? The technology was designed with the scenarios in mind, and many of the things that you saw announced for 2016, like the SLB, service insertion, so many of these concepts are the things that most of our partners have asked for after their initial deployments with HNV. So first up, data center extension. So the ability to have multiple enterprise, so multiple customers or business units, if you're an enterprise, connecting through a multi-tenant network virtualization gateway to access their corresponding virtual networks in the back. So this was the number one scenario. Pretty much every service provider we work with has deployed this, and it's the number one scenario here. So data center extension, hybrid networking, you have many names for this. Second up, using the same concept of the gateway, you use the NAT functionality. So we are able to publish servers that are sitting inside virtual networks and publish them on the external network of the gateway using address translation, okay? Here, we also benefit from the fact that we have a multi-tenant TCP/IP stack, and we are able to use the same gateway, although using different IP addresses in the front of the gateway, to then provide an external-facing service to servers inside those virtual networks. Okay. So here is also another scenario where there's some limitations to the product that most people, when they start, they're not aware of them, and they cause them some pain. So when we're provisioning a gateway, we are actually limiting for each of those virtual networks, we're actually limiting this to one IP only. So one tenant will get one IP on the outside. So if you're publishing a web server on port 443, for example, an SSL service, or port 80, well, you're not going to be able to publish more than one server on that interface, okay? So this has been the highest request we have so far. It's something that engineering is working on, so no announcements yet, but it's definitely something that's going to be corrected. So again, this was the second scenario that most of our customers have been deploying. An interesting variation of this scenario, and because we're using virtual networks, is to actually use them for test and dev scenarios where you can easily clone most of the virtual machines and create a new virtual network, create a new NAT, and have a very easy way to clone an environment and make it accessible for tenants, for developers and testers, and have a simple way to access this environment. So due to the fact that these are all virtual networks, virtual machines, this was one of the primary scenarios being used for the NAT scenario. So things to think about. Consider the stack if you're using Windows Azure Pack. Do not assume that everything that Virtual Machine Manager and Windows Server and the gateway role will be available to you. You have to understand things like only one, or the first address space that's created is being used, only one IP available on the front end of the gateway. So these are some, current limitations of Windows Azure Pack that we're addressing in the future. But if you have your own portal, then you have basically way more options in what services you create. And this is, if you think of Azure itself, which uses some of this technology, they have different options. If you think and you use Azure, you'll see that you have the option to connect virtual networks between themselves, because they are basically, they have other options as they develop their own UI for customers, right? So one critical element, if you think about the solution, is how you get in and out, right? The gateway becomes a critical point of this whole solution. So here, scalability and performance are key factors. So today, you need to dedicate a set of Hyper-V hosts to run your network virtualization gateways, okay? You cannot reuse hosts that you have for your tenant workloads. Those hosts need to be running only gateways. Each gateway is a set of virtual machines that are deployed in a failover cluster. This is how the gateway achieves high availability, okay? And you can provide a higher level of service. This is also something that's changing with VNX, so we're abandoning this failover cluster model for the gateway, and we're going for a scale-out mechanism. So each host can have multiple. So each pair of hosts, or more hosts, can have multiple gateway pairs, right? So if you think as a single gateway, as a pair of virtual machines, your two hosts will be able to run multiple gateway pairs, okay? Ballpark around 4, but it all depends to what your tenants are doing. So the connections coming in, the traffic that they're generating, that's all dependent. So there's not a hard guidance around this, but you should expect to run at least 4 gateway pairs. Each gateway defaults to 50 tenants, okay? Although the gateway itself, we support it more or less up to 100 tenants, it defaults, and we configure it through Virtual Machine Manager, to 50 tenants and 200 site-to-site tunnels. Again, if you have many customers, but they're basically very low in the traffic that they generate,
you'll be able to ramp these numbers up. So you'll be able to have more tenants running on your multi-tenant gateway. Okay. We've done quite some documentation on the interoperability with third-party VPN devices. So as we brought the solution to market, we started to hear feedback from the partners that were deploying and the challenges that they were having on the connectivity of those third-party devices to market. So there's documentation available, and there's at the end of the presentation, so if you download the slides later on, so at the very end, there's a set of resource pages where I've included the links to the guidance that we have for configuration of these providers, okay? So, we announced also, so during Ignite, we also announced the possibility to use GRE encapsulation as a way to augment the functionality of the solution, okay? So this was introduced originally for Windows Server 2016, but there's available today a backport of this functionality for Windows Server 2012. So in addition to allowing you to create site-to-site IPsec tunnels, you can also create simple GRE, which are basically a no encryption encapsulation. So it allows you to tunnel between networks and while maintaining the ability to have multi-tenancy in those connections. We'll demonstrate that in a bit more device. So this opens up more scenarios for these providers. So the number one is the MPLS termination, right? So when in many telcos or managed service providers that are providing also network services to their customers, before the GRE tunneling, we would need to terminate every connection in our gateway. So this wasn't possible for the scenarios, and thus we are introducing this GRE tunneling capability. So it allows the connection from the customer to be terminated northbound of our gateways, and then this device where the MPLS connectivity is terminated can do a GRE tunnel to our gateway and have the connectivity inside the virtual network be considered end-to-end from that customer's perspective. It also allows integration and interoperability with traditional physical devices and networks. So if you have a load balancer or an IDS appliance or something that understands only traditional networks, but you want to put that device in the path of the service or interact with it from a virtual network, GRE tunneling can also be used for that particular scenario. So let's take a look with a bit more detail. So here, a service provider network that has, for example, a metro network or MPLS or anything that they use that they need to maintain and terminate a connection on some device that's not our gateway, can then use GRE to connect to our gateway and maintain a consistent and isolated tunnel all the way to the inside of the virtual network, okay? So the requirement is that that device supports GRE, which is a very common protocol in networking devices these days, but also that it has also some sort of virtual router functionality, router domain, so many terms for this across the industry, but it's also something that you'll see in any device that's basically executing this role at a communications provider. So the ability to GRE, to have GRE keys, we're using that functionality to be able to separate the traffic that's coming in and forward it, so encapsulate it with GRE and deliver it to the right virtual network. So the second scenario is when, for example, a managed service provider is providing services but has a mix of virtual networks and physical servers in their element, right? So if you have a customer that has a hosting contract with you, you have old servers or anything that you need to interact that's not necessarily inside a virtual network, You can also use the GRE tunneling functionality to connect those physical networks independently to your gateway using the GRE functionality, okay? So this also opens many possibilities for interoperability with also other virtualization solutions, okay, that do not necessarily have NVGRE capable endpoints. Another scenario that was possible with GRE is the concept of a shared physical network. Okay, so many providers have shared management solutions. For example, update services, a monitoring solution that they have that needs to access these virtual networks. Here, there's some concerns around the ability or the requirement to have some address space that any of those can consume. But GRE tunneling can be used as a lightweight way to connect that shared network, so whatever is running in that traditional physical network, and connect that independently to each virtual network. So finally, the addition of network services, okay? So one of the biggest requests we have with the current solution was the ability to do, for example, load balancing of machines inside a virtual network, right? So if you think of the current functionality on the edge of the gateway, so it's side-to-side tunnels, NAT, the obvious missing links are some sort of firewall capability that, although is there, is not exposed to the tenants in a consumable way. So an admin can definitely configure our network ACLs there, but this is not something that's tenant consumable, and load balancing. So the GRE tunneling capability was also capable of addressing this scenario, although without providing that self-service experience. So there's no UI in Windows Azure Pack, for example, that allows you to take advantage of this. So everything still needs to be configured by the provider. So here, a tenant can access any service that's provided by the device that's sitting up there, right? It can be a load balancer, can be an IDS, can be anything. So anything that you put in that path. And due to GRE and the ability of that device to also support virtual routing domains and GRE keys, it will be able to provide any service that this box can provide. Okay, so again, load balancing is the number one function that people are using this for. So this device, and coming back to that initial, if you think of that initial or one of the earlier scenarios where we were talking about shared networks, if you think of the internet, for example, or any network that's able to talk with this device, can then be used to access also resources that are inside those networks, right? So it can do, you can benefit from GRE coming from the inside of the GRE tunnel, but you can also benefit coming from the traditional physical interfaces that these devices serve for you. A bit outside of the context of the work we're doing with service providers, we also had others. So we work with our consulting arm at Microsoft and other partners. And we've had some feedback on the utilization of HNV in enterprises. Okay, so think of the previous scenarios as somebody that's providing this to external parties. But many people have tried to use HNV in an enterprise context for the agility of the creation of the virtual networks, for the agility of deployment, right? And here, many ways are available for you to actually provide the service and use the technology, okay? There are some benefits in the sense that if you use Windows Azure Pack, you can have your tenants, dev teams, testers come in, create virtual networks, provision things by themselves, okay? But the vast majority of the scenarios for V1 were definitely targeted at service providers and the ability to run, for example, overlapping IP spaces and similar scenarios where enterprises were not the number one customer for these features, okay? But still, you can use the technology, and the same concepts apply. So you just have to think of how you can leverage the gateway in its many modes of functionality in the GRE tunneling, and leverage those to provide connectivity for the customers accessing those servers. So you can use a branch site, any remote location can use site-to-site tunnels to access a virtual network that's sitting on your enterprise data center. Inside your enterprise network, GRE tunnels become one higher performance option to connect also to those virtual networks. So instead of having inside your own internal network to connect with, for example, a site-to-site tunnel, which is heavy with encryption, right? You can use GRE in this scenario. It becomes a bit more high performance. There is also the ability to do NAT, so just publishing through NAT, but again, we hit those one IP per virtual network limitations, so publishing the types of services and the ability to, or the lack of ability to set or have an easy way to set firewall rules and load balancing made the scenario a bit challenging for enterprise consumption. Finally, the gateway, so we mostly refer to it as a multi-tenant gateway, can also be deployed in this forwarding gateway mode, which is for single tenants, right? And here it requires basically, a one-to-one mapping between each gateway and the virtual network that it connects. So for every virtual network that you have, you need a gateway deployed to access this virtual network, okay? So there's no multi-tenancy. It basically becomes a router in and out of that virtual network. Any questions so far? I hope sure.
So just to clarify, on the previous slide, so as a service provider, we're typically doing server publishing and whatnot directly. In this scenario, would allow us to say, for instance, just deploy a big IP device using GRE tunnels.
Yeah.
Then rather than the H&D networks, and it basically skips the whole single IP external publishing issue, and just route all the customer traffic, all the publish traffic through the big IP device, for
Yes.
example, and go from there.
That is one of the scenarios. It's been used exactly like that. Okay. So the question was if you can use, for example, an F5 big IP as this device sitting at the top, and you can use any of the functionality that this device will provide, load balancing or publishing, and then use the GRE tunnel in the back to connect to the inside and load balance the virtual machines that are in there, for example, or just provide some address translation into that. Going forward. So what are the big learnings here as people have deployed this? And the number one thing we've seen that caused pain and suffering as people went and deployed this was actually starting bad. Technology, if you follow the existing guidance, so if there's plenty of guidance, Scott and Greg did an end-to-end demonstration of how to deploy technology in a 1-hour session. So it is not hard, okay? But it is sometimes hard to map it to your context and make sure you're not making any mistakes, okay? So these are some of the rules that we're thinking that are helping customers be able to start small and deploy easily, but then allow them to grow as they scale their deployments, okay? So we've seen many customers that deploy and use network virtualization isolation mode for all their networks, because it's the default that's in System Center Virtual Machine Manager. And although you can definitely make it work, it is definitely not easy to scale any deployment. It's actually not a good way to start, so you shouldn't be doing this. You should configure at least 3 different logical networks in Virtual Machine Manager, okay? And only one of them should be using network virtualization isolation, okay? And this is the network that has your provider address. So The IP pools that you're defining for this network are the IP pools that you want to use to move HNV traffic around, okay? There are more advanced scenarios, so you can have more than one of these, okay? So you can have System Center Virtual Machine Manager managing independent provider address networks, okay? But the virtual machines that you have running on one will not talk to the virtual machines that you have running on the other, okay? Think of them as islands. I would definitely not encourage anybody to start like that or to think you should start only with one, and once you have a clear understanding of the solution, or if you hit something that requires you to build a second one, then think about that. Okay. One logical network for all your management functions. Okay, so live migration, your management network, or you have your domain controllers. So anything that you use on your clusters for data center traffic, you should also contain it in one logical network. And finally, a third logical network for the front end of this gateway. Okay, and here you definitely need to separate this. We've also seen customers that would just create one big data center network and have their internet-facing networks there, their management networks there. And this will confuse System Center Virtual Machine Manager when it needs to assign networks to the gateways, okay? So small things that would be done very early as you were starting to build your environment would have not so easy to track errors, so it would be very hard to trace the reason of the failure that happens sometime later when you're configuring your gateways, for example, back to this design decision early on, okay? So if you do these three, you definitely have a good way to start, and you can leverage all the filtering ability that Virtual Machine Manager provides by host groups, by the ability for you to create multiple network sites, and the ability to use uplink port profiles, okay? And the uplink port profiles are the most important concept that you have to understand when deploying network virtualization, okay? So let me bring this in a bit more visual reference, okay? So a typical network virtualization deployment will have at least 3 host groups in System Center Virtual Machine Manager: your compute host group, your management host group, compute host group, and your edge host group. So management roles, your tenant, your Hyper-V hosts with your tenant VMs, and the roles hosting the network virtualization gateways. So the physical devices where you're connecting to, you need to define independent uplink port profiles, okay? And this is the one mistake we've seen people make the most, where they just use the first one they create, so that they use them for all these host groups, okay? So this prevents segmentation or proper filtering of the networks that are visible to each of these host groups, okay? So you should have a management uplink port profile, a compute uplink port profile, and an edge uplink port profile. And as you assign the network sites to these uplink port profiles, you need to make sure that the right networks are only visible to the right uplink port profile. Okay, so management is something that must be available to all of them. So, for example, to reach Active Directory, the provider address is something that the management doesn't need access to. So only the gateways and the Hyper-V hosts will need to see this address. And for example, the gateway front end is only required to be visible by the gateways. Okay. Something that may change with server vNext, right, as we change some of the way the gateway is working. So this seems a bit complex because, well, if you can deploy with one and you have only one front-end network, one PA network, things will work if you just keep things a bit more simple. But the problem is, if you want to deploy, for example, another set of gateways to provide service on another network, and you haven't done this, you'll have to basically undo all this work to then create this object so that you can properly filter those. So the moment you try to grow and you didn't start like this, you'll feel the pain. Have you ever had to deal with Virtual Machine Manager dependencies on networks? So if you try to remove some of that, you'll hit that to the extreme level of the logical switch on the host. So you had to remove the logical switch on the host, unplug every virtual network. It's painful, okay? So this is why this guidance is there. So independent uplink port profiles for each of the host groups or roles of hosts that you have, and then logical network sites to properly define which networks are visible to each host, okay? This mechanism also allows you to do some more advanced filtering, okay? For example, if you want to route your provider address or provide independent front-end networks for your gateways. So the design and scale of the PA, that provider network, most people would start with just assigning a /24 to this and not really think about it, right? But if you start to grow, you're going to hit scale problems. You have to understand how those resources, those provider IP addresses are consumed, okay? So each host that hosts a virtual network will consume a PA, okay? Each gateway will consume 3 PAs. And if you start to see how this works at scale, you'll soon see that a /24 will probably, if you have any scale as a provider, you're going to consume these IPs in no time, right? So start with a /23, 32, something that gives you some headroom, okay? Here's a visual representation how this is consumed. So a virtual network on one host consumes 1 PA. If you add a second VM, nothing happens. Still 1 PA consumed there, okay? A second tenant comes in, and then you have 2 PAs consumed there, okay? As you move there, so for example, you have 3 virtual machines on a virtual network, again, 1 PA consumed, okay? If you extend that blue network and now you have 5 virtual machines on that blue network, but they're spread out in different hosts, again, 1 PA consumed for that extra blue network on the second host. And the gateways, 3 IPs at a time. So anytime you provision a gateway, you're going to consume 3 provider addresses, okay? So understand your growth and adjust accordingly. So recommendation, don't go with /24, just go with something bigger. These are internal address spaces. You can use anything that's available to you. So it's not a big concern. It's just don't start with the /24. So some other guidance that's important to be aware of. You can use only one logical switch. The uplink port profiles that you connect them to the actual network adapters is what matters. But we've seen some examples where it would have been a good idea to at least separate the management from your compute instances, okay? Although this is not hard guidance, this is something that you can definitely adjust to your preference. But we've seen some scenarios where having that separation would have been a good idea. And it's also the way you can manage different extensions. So if you have extensions deployed in your environment, the logical switch is also the way you manage those. Then jumbo frames. So jumbo frames are critical. If you understand how network virtualization works, there's an encapsulation that removes your ability to have the regular MTU, so the packet size inside those virtual networks, right? And we do an automatic reduction of the MTU size when not using jumbo frames on your provider address, okay? Windows will work automatically for any guest operating system that's Vista 2008 or higher. Linux has had a patch done recently to the kernel, but it's still not widely deployed, okay? So not every Linux distribution out there is going to have this automatic ability. So if you're having trouble, for example, on a Linux machine to talk to the outside, it can be related to the MTU size, okay? Also in the resources page of the presentation, I point you to some guidance on how to address that and to the Linux kernel patch that you need to have in order to set this, okay? If you want to have the default MTU size in your customer address, you need to run jumbo frames on your provider network, okay? So enable jumbo frames on the outside. This allows a bigger frame size, and meaning the inner frame, the customer traffic, can use that regular 1500 size, okay? So other scenarios with multi-home guest virtual machines. Remember when I said the .1 address is automatically inserted? So if you're routing, for example, you have two virtual networks assigned to a virtual machine, both of them are configured by default with default gateways. So this can lead to some interesting scenarios or failure in communication. So if you want to have multi-homed virtual machines in combination with network virtualization, you do have to manage the routing inside your virtual network, okay? So you can attach regular PVLAN, VLAN networks there, but always you need to manage the routing, okay? And remember, the .1 address of each network is going to be the default gateway there on a virtual network. So around the gateway deployment, there are many ways to deploy these gateways, right? People have learned how to deploy them manually. In the end, it's a very simple process if you're fully familiar with it end to end. But we provide a service template for Virtual Machine Manager that contains all the hard work, okay? However, this service template was shipped with a set of requirements that not all people have on their environments. The biggest one is the need for a scale-out file server, right? Our SMB3-based storage. Not a lot of customers had this, or most of the customers didn't have this, so we were faced with how to modify the service template to deploy that in a traditional Hyper-V cluster using SAN, okay? So these are some of the things that you need to change on that template in order to follow the best practices, okay? So the template comes with a small amount of processors, dynamic memory, so you need to increase the memory, set it to static, increase the number of processors. So depending on your scale, how many tenants you're expecting, you should raise those numbers, okay? So in order to be able to deploy to a SAN, you should also remove the disk classifications, okay? You also need to set the hardware template of the service template, so the virtual machine itself that's defined there. You need to configure it to be highly available, okay? And I'll talk a bit more about this later. And you should pre-populate that template with everything as possible. So gateway deployment is not something that you do every day. So it's not when you're deploying that you need to have in your head all the configuration that you need to put on provisioning time. So you need to pass IP addresses, gateway name. You have to pass a set of parameters to the service template in order to provision it. So go to the service template properties and pre-populate with a description of what you need to put in there at the time, okay? So again, the gateway virtual machines, as I mentioned earlier, they're a gateway, they're a failover cluster that runs in two guest VMs, okay? And if you do these changes here, okay, you're going to be able to, so these machines will be highly available. That means that they can live migrate, they can move around in that cluster, right? But for network virtualization gateways, they must not, okay? So you need to prevent them from moving. The easiest way to do so is to remove those resources, okay, in failover clusters. So when you deploy any virtual machine in high availability, it's going to have an associated set of resources in that cluster, okay? So make sure that if you do these changes, when you deploy the gateway, remove those resources, okay? The only thing that moves on the Hyper-V host, so there's a gateway node here, another gateway node here, is the resources that are inside the guest cluster, okay? And the provider address that sits on the host cluster, and I'll show that, okay? The virtual machines need to stay where they are. Even if you're patching the host, just shut everything down, let the resources fail. Do not ever put the same machines, or the two virtual machines of a guest cluster on the same node. So network virtualization will stop working. Okay. And if you have some sort of complex network configuration, when you're defining the logical networks that are used by the gateway, you need to keep the routing in mind, especially if you need to route to reach your domain controller. So when you're doing the domain join of the gateways, they need to reach the domain controller. But most gateways are deployed on internet-facing roles. That means that when you're defining the IP pool, you set the default gateway to that front-end interface of the gateway. So this can cause confusion in routing, and it can cause the deployment to fail because the machine will fail to locate the domain controller. So we usually also customize the template to add the internet routes later on and keep only the IP pools, so the definition of the IP pools, only for the management network. And then you just add a small script to the template to add the default gateway for your internet-facing networks. Okay. Also, another usually missed step is the reservation of the failover cluster IPs itself, right? So the network where you're provisioning, you're automatically assigning IPs for the gateway nodes, but there's one extra IP for the gateway cluster itself, and you should reserve a range for this, okay? So that you never ever have the situation where some deployment will fail because the IP that you're trying to use for the cluster was already in use for some situation. So you should have a clear boundary of IPs to use on that network. So these are the resources that you see when you're deploying a gateway. So this is the host, and for every gateway that you deploy, every virtual network there, every tenant, will have a PA resource, okay? And if you see on the host virtual machines, so when you deploy, if you ever come and see this and you see here virtual machines, remember, you have to remove them, okay? They should not be highly available. They should not move. Inside the gateway cluster, you're actually going to see the gateway resource, okay? So guidance, never move this one. If you need to move the gateway from one node to the other, move the in-guest one. This one will follow. And they always need to be synchronized. So they need to be on the same, so the physical host has this resource, the guest host has this resource. So if they're both on one, everything is okay. If they both are two, everything is okay. For any reason, they do this, or if a VM moves and things get out of sync, you will have trouble getting in and out, so traffic getting in and out of the gateway. There's also some optional parameters that you can use to modify the scalability of the gateway. So remember default, for example, of 50 virtual networks or tenants. You can use some of these parameters to modify those configurations. So this is done on the connection string. So when you're adding this network device, so this gateway to virtual machine manager, there's a string of mandatory parameters that you have to specify, and you just need to add some of these, okay? The service template that we provide has additional parameters that you can use in many situations, okay? So some of the technical pitfalls that we've seen. People trying to stretch HNV across sites, okay? Although it is more or less simple to do, if you consider only the hosts, because basically it's all, as long as you have a routable connection between them, you can stretch an HNV network easily, okay? But if you think of the gateway and the failover, if you're familiar with failover clustering and the requirements of the nodes to be on the same subnet, suddenly when you think of the gateway, especially also the front end of the gateway, which is typically an internet-facing network, stretching this across the data center is not so trivial, okay? So you need layer 2 stretching. So typically is not as easy, or it's much more complex than stretching the host side of this, okay? So while some of our documentation hints at the possibility, for now, we prefer to keep the scenarios not supported, okay, or not recommended. And you should always think of Hyper-V replica and Azure Side Recovery as the mechanism to support the movement of virtual machines from one data center to the other. Okay. Another critical factor is your choice of network adapters. Okay. For any sort of performance, you need NVGRE task offload. Greg and Scott on his sessions, they showed some data, hard data around this. So if you consider performance, if you need hard performance, if you need to stretch your 10 gigabit network adapters, NVGRE task offload is critical. Any adapter that's going to have this will also have VMQ support, and these two are critical. The stability of the drivers, so test and at scale, is also a factor. There's been many improvements over the last 12 months in our ecosystem of partner. So if you had issues in the past, be sure to bring those adapters to the latest firmwares, latest drivers, and take a look again. So HNV is not only technology, it's also people process. Many partners try to do this just by the server team requesting a couple of VLANs from the networking team, and then basically this is hid everything from them. The network team would receive some sort of ticket that a customer was unable to connect through their VPN, and first-tier support would route this to them, and they would have no clue of what was happening. So everything, as you think about adopting software-defined networks, is a combination of everybody that's involved. So if you're deploying this alone without the sponsoring and being actually a combined effort with your networking team, you will have a tough time not deploying, because you'll easily deploy this. But if you run into trouble, or if your network team requires insight into what's happening, you'll definitely have a hard time. So monitoring and troubleshooting, we ship an operations manager management pack for the multi-tenant gateway. Some people failed completely to understand how it's deployed. It's not easy when we're using a gateway cluster. The whole process is documented on the gateway management pack documentation, okay? Some people, when using operations managers, just download the management pack, and then it fails to discover the gateway, okay? You can either there's a set of steps that you can do manually of adding a cluster name to the gateway cluster that allows discovery, or you can configure Virtual Machine Manager with a set of registry keys that automatically create this name for you, okay? But this step needs to be done in order for the gateway management pack to work correctly, okay? We also provide a set of troubleshooting guidance. Again, in the slides, in the last slides of the presentation, you'll find links to this troubleshooting guidance, so how to use network monitoring tools, what you should be looking for, how to get that data from Hyper-V in order to properly understand the flow of traffic through HNV. So partner solutions and ecosystem. NVGRE task offloading adapters is critical. NVGRE support on the path of the packet, so your switches, your routers. This will allow the network team to actually have visibility into those, okay? So new silicon that's in the market already for some time. So if you have older networking equipment, there's a good chance you don't have this ability. But if you're purchasing and you're interested in HNV, this should definitely be something you should be looking at. There's also a set of partner solutions. So F5 can also work as a gateway. So it can replace our gateway for routing scenarios, okay? It doesn't lose the self-service aspect of Windows Azure Pack, but, well, you need to understand what your scenario is. A10, Huawei, Iron Networks, all of them have shipped gateway solutions or announced their intention to ship. 5.9 provides a WAP extension and a virtual firewall and a security solution for Hyper-V that can integrate with virtual networks. So moving forward, most of the things or the primary aspects that we've heard as well, load balancing, a firewall solution that can work inside and on the edge of the virtual networks, improved ability to actually monitor the usage of the traffic, so the virtual networks. And many of these things are things that are already planned, okay, and you'll see them come in future update rollups for Server 2012, okay, for the current solution. Others, like software load balancing, the network security groups, are things that will come, okay? So the solution will change, and some of the things that were introduced already by the engineering team this week already hint at some of the change that's coming and how the architecture of the solution will change. But deploying now gives you a critical insight into how HNV works, how it moves data around, how the gateways function, and these things will not change. So starting now is a good preparation for what's coming next, right? And if you take a dependency on on the current solution for something, it's actually something we want to hear about. So give feedback or what's missing, what are the scenarios. There are many user voice forums that are being published by the engineering teams that allow you to provide feedback, request new features, or vote on existing features. And those things are very, very, very important for engineering, and they will actively look for your feedback in those places, okay? So questions, anything? No? Okay, sure.
This feature of theory tunneling, is this exposed to the Azure Tech?
No, so it's an admin side only capability, okay? So you're going to, it's a hotfix. The link for it is also in the end of the presentation. It's also in UR5 of VMM, so you need UR5 of VMM, and you'll be able to create those tunnels as an admin, so you'll be able to augment the functionality, okay? So the interaction of GRE is always with some sort of physical device. So Windows Azure Pack is not equipped with the ability to then do the other side of the connection. Even if we did something on our side only, you need to configure the device also on the other end. Sure.
What is the advantage if the local direct switch supports NG?
The ability for the network administrators to actually see what's going on. So they will see those virtual networks. The tools will be able to consume that information. Okay? So instead, yeah, there's no performance advantage of any kind, right? Because in the end, they're just moving a traditional packet, right, around. It's either a traditional IP frame because, yeah, exactly. But it's critical on the network adapters, okay? So on the hosts serving the gateways, task offload there is very, very important, okay?
Is there any talk about how the kind of migration experience might be if you're current, if you were to deploy this now and then the magical future version comes out, what that migration, the new version might be like?
I don't have anything to share at this point. Anand, maybe, is there anything around migration that we were able to talk about at this point? To VNAX, can you come to the mic, please, Anand? Sorry.
Yeah, actually, we are still actively working through the Windows Server 2016 stuff, and migration is one thing that we are looking at. So hopefully maybe in about 4 to 6 months' time, whenever the announcements happen, you should be able to hear more. Yeah.
Okay. So thank you. Safe travels home. I hope this was a good use of your time, and feel free to reach out. My Twitter alias is on the first slide, so if you need some support, just reach out. Thank you.